Hi, welcome to Kodevo. In this episode of algorithms, we'll be looking at linear search. So, when you start learning algorithms, this is one of the first algorithms that you'll learn, and it is quite simple and obvious, and it's just a naive approach. So, when you think of this problem, you might actually come up with this particular algorithm all by yourself. You don't have to even learn it per se, but we'll go through this problem statement. We'll learn how this algorithm works, and we also try to code this algorithm in Java. So watch the whole video. So let us consider this particular scenario. So there are a group of men standing in a line, and you're supposed to find the man with the blue colored hair. Quite suspicious though. Anyways, so what you will do? You'll first examine these men one by one, looking at their hair. If the first man has black hair, you'll move them aside and look at the second one, right? So you'll keep doing this until you get a man with blue colored hair, right? The example might seem quite tough, but this actually is the logic of linear search. So when you compare this with the situation that we'll actually be using is, you're given an array. It might be an integer array, it might be a character array, it might be a string array, anything, and you're supposed to find one particular element in it. It might be an integer, it might be a string, depending on the array, doesn't matter, but you're supposed to find it. So what you have to do is, just like when you wanted to find a man with blue colored hair, you're going to look at every single individual element in this array, right? So it can be string, it can be anything, but for simplicity's sake, we'll consider integer array. You are going to look at these elements one by one, and you are going to check if that particular element is in fact the element that you're searching for. If it is, you are just going to return the index of it. If not, you'll keep looking for the element that you're searching for in the next indices. So you'll understand this a bit clearer when we do with an example. So here we have an array, and this array is of size 6, okay, and I have given the indices of them here, 0 through 5. So the values that are present in this array are 5, 3, 4, 2, 1 and 7, okay, in this order. Notice that these numbers are not in any particular order. I'll tell you why this is in a minute. So these are numbers, and you are supposed to find 2, the value 2 in this array. You are going to check if 2 is present in this array. If it is present in this array, you are going to return the position of it, or rather the index at which the element 2 is present. So you are going to find 2 in this array, and you are going to return the index of it. So how do we proceed doing this? So this is very similar to the analogy or scenario that we saw, right? You are a group of men, an integer array. You are going to find a man with blue hair. You are going to find the element of value 2. So exactly like that, you are going to go through one by one. We'll just traverse this array and find where 2 is. So what you'll do, you'll use a for loop. Like, now don't worry too much about the implementation. When we go through the implementation, you'll get a better idea. But what we are essentially doing is, we are looking at the first element. The first element in this array is 5. Is 5 2? 5 is not 2. So what you'll do is, you'll move on to the next value. Next value is 3. Is 3 2? 3 is not 2. So you'll move on to the next value. 4. Is 4 2? 4 is not 2. You'll move on to the next value. 2. Is 2 2? Sounds weird, right? 2 is in fact 2. So you are going to return the index of it. That is 3. Okay. 3 is the index at which the value 2 is present in this array. So you are going to return 3 as the answer. Now, this is basically linear search. Okay, so you are going through the array, you are traversing this array one by one, one element at a time, comparing it with the element that you are searching for. If it is same, you are going to return the index of it. If not, you keep moving. Now, one more question arises. What is that? What if the number is not present in this array? So this array has like 5, 3, 4, 2, 1 and 7, right? So if I am going to search 10 in this array, what will happen? So you'll have to think of that as well, right? So you are going through this array, and once you get through the array, or when you reach the last element, and even then if you don't find the element that you're searching for in this array, in that case you will return -1. Why -1? Because generally we are using zero based indexing, right? So the index starts from 0 and goes to the positive numbers, but there will not be a negative index, right? So if an element is not present in the array, you will return -1, denoting that that element is not present in this array. So that is what you are going to do for that. Now we'll first implement this in Java, and later we'll move on to the time complexity of this application. So now here I have a main function that has the same array and the search value, and it is passing this array. I'm sorry, I didn't pass the array yet. Int arr. Okay, so I'm passing this array and the search value to this function called search. Now what you're going to do inside this search function, we are going to implement the exact algorithm that we just saw. Okay, so first what we'll do, you are going to loop through this array. Okay, so I'm going to use a for loop, int I equals 0, I less than, and here comes the problem. You don't know the size of the array. How long will you traverse this or how long will this for loop keep going? Up until it reaches the last element, right? So you need to know the size of the array. So arr.length. Okay, now this is the for loop. It goes from 0 to arr.length. So it traverses the whole array, and we are going to see if the index or the element that you are currently looking at is in fact the element that you are searching for. So if arr of I, that is our current element, equals yes. If arr of I is equal to the value that we are searching for, in that case we'll just return the index of it, right? So return I, because we are using zero based indexing and the value of I is running from 0 to n-1. So we are just returning I. Okay, now at the end of this for loop, we discussed one scenario, right? If the element is not present in this array, you will return -1. So if the element is not present in this array, our algorithm will go through every single element in this array and will come out of the loop. Okay, so after coming out of the loop, if the algorithm comes out of the loop, it means that there is no element with the value we are searching for. So in that case, we are just going to return -1. I hope I am making things clear. You are searching for every element in this array. If it is present, you are going to return the index of it. If not, it will definitely come out of this loop, right? Because it is going to search every element and it will definitely reach the last element, and even in that case it will not find something that we are searching for. So the return statement will not be called and it will come out of the loop, and when it comes out of the loop we are just returning -1, saying that there is no such element in this array. And this is the coding part of this question, and we'll just try and run this. So I'm not passing array as argument, right? Okay, now I'm doing it. We'll just run it and see if it is working. The answer should be 3, right? Yeah, 3. So it is the 4th element in this array and its index is 3, obviously, because it is zero based indexing. Now the time complexity of this algorithm is order of n. Okay, so when it comes to time complexity, there are like you can assume like there are many things, but in simple terms, that is the best case scenario. Okay, so in best case scenario, the element you are searching for is present in the first index itself. Okay, if it is an array of size 100, it doesn't matter, because the element that you are searching for, the first element is the element that you are searching for. So in that case, the time complexity is just order of 1, because it is always constant. No matter what the size of the array is, the element that you are searching for is always at the first index, right? So in that case, the time complexity is always order of 1, constant time, because you will always find it at the first index, or any index for that matter. If we constantly know that only this much iteration is going to take for any sized array, we can say that as order of 1, constant time. But that is not the case, right? Because the element can be at any place, and in worst case scenario, you will find it at the last place or you will not find it at all. If you not find it, you are going to iterate through every single element in this array and you are going to check if every single element in this array is in fact the element that you are searching for, right? So you'll iterate through whole of this array and you will not find it. So in that case, you are making n comparisons where n is the size of the array. So in that case, the time complexity will be order of n, because that is the worst case time complexity. You are going through every single element in this array, and that usually is what we mean when we ask time complexity. Okay, the best case, they will mostly not ask you the best case. When they mean time complexity of a program, they just mean the worst case time complexity. And in our algorithm that we just implemented, the worst case is order of n, because if the size of the array is n, our algorithm will make n comparisons to get through the value that we needed, or to find that if that element is not present in this array. So that is that. And it also has a lot of things like we ignoring the coefficient and other things, but just to keep it simple, this is the time complexity of this algorithm. Now this is linear search, and if you wanted to learn just this is fine. But there is one more interesting thing, or one more interesting approach to solve the same problem. Now we'll look at that. We'll come back to the same scenario that we started our question with, right? We have a group of men and we are going to look through for the man with blue hair. So if only you are looking for it, you are starting from one end of the group of men and you are working your way through all the men up until the last one. Okay, but what if you had two men or two of you? You cloned yourself and you are two now, and you can search from either sides, right? Just an imaginary thing. Don't worry about it. What I'm trying to tell is, we were checking for the condition if the element is in fact the element that we are searching for only once per iteration, right? So we are looking through we are seeing the first man. If he has blue color hair, he is not, so we are moving to the next man. Now what if we can do this from both the sides? Okay, so I'm just getting a help from some other person who is also searching for the person with blue hair for me, helping me from the other end of the line. So both of us are starting from the ends of the line. Line has obviously two ends, so both of us are starting from two ends and we are working our way through all the way to the middle. Okay, so this is the improvised logic that we can use. Okay, it will not improve the time complexity. The time complexity will still be order of n, because in the worst case scenario you will be you will be going through n by 2 iterations. But even in that case, the number of comparisons will still be n, because for every single iteration you are going to check if two numbers are the numbers that you are searching for. So I may be confusing you here. So we'll go back to this array. We have this array with 6 elements, right? 0, 1, 2, 3, 4, 5 is the index, and 5, 3, 4, 2, 1, 7 is the elements or the values in the array. Now we are searching for 2. Now in the earlier case, we started from the left side and searched if every index or every number in this array is the number that we are searching for. But instead of that, this time what we are going to do is, we are going to search from two sides simultaneously. So in the first iteration, we are checking if 5 is 2 and 7 is 2. Okay, we are doing these both checks, both conditions. We are checking these both conditions in one iteration. Okay, we are just assume in the previous thing we are checking for AR of I equals yes, right? Let us consider two variables I and j. I is at 0th index and j is at 5th index at the both sides of the array, and we are checking if both these values are in fact the element that we are searching for. If not, we'll bring both of them closer. So I will be I plus plus, j will be j minus minus, and now we'll be comparing the same thing. So this is one more approach that we can use. So as you can see, 5 and 7, both of these are not 2. So we'll increment the value of I pointer, or the hand that is looking for in the starting, and the one, and we'll decrement the one looking at the last. Now we'll be looking at 3 and 1. Now if 3 is 2, not 1 is in fact the 1 is not the value of 2. So this condition fails as well. Now we'll move on to the next one, and we are at 4 and 2. Is 4 the value of 2? No. Is 2 the value of 2? Yeah, of course yes. So now in that case we have found 2, and that will be returning. So instead of searching from one end and moving to the other end, we are searching from both the ends and coming towards S. So if the element is present in the last index, right, the element present at the last index was the case scenario for the previous algorithm. So we will have to compare every single element before going to the last one, and that is being reduced in this case. The best case or even the worst case has been reduced, you can say, because the last element you can find it in order of 1, or the best case is order of 1, because even if it is present in the first index or the last index, you will find it in one iteration. It still will take 2 comparisons, but you will find it in one iteration. So that is the improvement that we have for this algorithm over the other algorithm. But even then, the time complexity will still remain the same, because in this case, the worst case will be the elements at the middle, right? So both these have to work all the way up to the middle to find the element at the middle, and in that case you can say that we have made n by 2 iterations, but still the number of comparisons is n, and also we'll ignore coefficients while calculating time complexity, so that is that, and still the time complexity will be order of n. So it not actually is that efficient per se when compared to the previous algorithm, but it's a cool new way of implementing linear search maybe. And you can use it, but one simple condition is that when you are required to find the first occurrence of a number, or when there is duplicates in this array and you are required to find the first or last occurrence, this cannot be used, because we will not know which one is going to come first, because we are traversing from 2 ends, right? So in that case you cannot use this algorithm, but other than that this is good as well. And the first one is the conventional one which everyone is going to use, so that is the important one, but you can learn this as well. It might be useful, maybe. Okay, now we'll try to implement this as well. Now let the rest of the functions be the same, and I'm just going to modify the search function. So I'm just going to create 2 variables, I and j. I equals 0, j equals arr dot length minus 1, just representing the starting and ending index of this array. Okay, now we are going to iterate, right? And the condition or the loop that I'm going to use is while loop, and the condition is while I less than or equal to j, because the loop has to stop at the middle, right? I don't want them to overlap and go this way. They are coming from both ends, so they have to stop at the middle. So the condition I am giving is I less than or equal to j, and inside this loop we are going to check 2 conditions. One is if arr of I equals yes. In that case you will return I. Okay, the other condition that you are going to check is arr of j, because we have 2 pointers now. Earlier we had only one moving from the left to right. Now we have 2 pointers, left and right pointers, moving towards each other. So we have to check if both these pointers have the value yes, right? And if arr of j is equals yes, we are going to return the value j. And for every iteration you are going to increment the value of I and decrement the value of j to make them come closer to each other. And even after this loop, if we don't find it, you are just going to return minus 1. Okay, I think that is it. Now I'll just run this code again and we'll see if we get the same answer 3. Yeah, we are getting the same answer 3. So hope you understood this logic. The first one is very simple. You are having an array, you are going to find a particular element in it, and you are just going to iterate through this array and see if every number in this array is the number that you are searching for. If one of the number, if you find the number that you are searching for, you are just going to return its index, and that is it. If not, you are going to keep working your way through this array. If you don't find this element in this array, you are just going to return minus 1. This is the simple approach. This is linear search, that is it, and its time complexity is order of n. It has no space complexity because we are not using any extra space. The second one is that the same approach, but we are just going to use 2 pointers and you are going to search this element from 2 sides of this array and you are working your way through it. And It also has the same time complexity, but I thought it might be cool to share this with you. Okay, anyways, that is it. So hope you understood the linear search. If you have any questions, put them in the comments and we'll get back to you as soon as possible. And stay tuned for the next episode of Algorithms. Thank you so much for watching. See you in the next video. Bye.